All right, the clock on the wrist says it's 3 after the top of the hour. Welcome everybody to the October edition of September edition of the OpenSSF's Tech Talk webinars. Today we're going to be talking about securing the AI lifecycle, talking about trust, transparency, and tooling, the 3 T's in open source. We have assembled an amazing panel of experts to kind of share their wisdom and experiences. So as a reminder, uh, take a minute to familiarize yourself with the Zoom interface. There's a Q&A button on the bottom bar. So if you have questions for the panelists, please go ahead and select that. If you haven't yet, and I don't know why you wouldn't, please consider following us on the assorted social media platforms, LinkedIn, Blue Sky, Mastodon, and others. Before we jump into it, just like every Linux Foundation meeting, we are governed by the LF's Code of Conduct, where we want to treat each other with respect and provide a harassment-free experience to allow everyone to kind of come together and collaborate. So if you're curious about the specifics of the code of conduct, please follow that link. Next slide. We also are governed by the antitrust policy, where the LF helps create a neutral platform for people from different organizations to come in and collaborate. And this is, again, how all of our projects and working groups and all of our efforts work together. So if you want to read more about our antitrust policy, please follow that link. Next up, today we've kind of gone through the housekeeping. We're going to do some introduction to our amazing speakers. We're going to jump into, we have a MLSecOps white paper we're going to talk about. We have a model signing and trust in AI artifacts project that I'm sure you're all excited to learn more about. We also are talking about some new things on the horizon, some opportunities and emerging efforts. And then we'll provide plenty of time at the end for Q&A, and we'll have some time for a couple announcements at the end. Great. I'm Krob. I'm the least interesting person here. I am the chief architect for the OpenSSF. I help the community go fast, and I remove blockers. Next slide. Sarah, would you like to introduce yourself?
Yes, Sarah Evans. I'm a distinguished engineer with Dell Technologies. I bring a background in IT and security operations to helping understand how we want to secure this new evolving space related to AI. I'm very excited to be here today at this Tech Talk, kind of having this conversation with the panelists and with the attendees. Thanks.
Thank you. Next up, Mihai. Could you introduce yourself, sir?
For sure, thank you. Hello, everyone. I'm Mihai Marusac from Google Open Source Security team. I'm leading the OpenSSF AI/ML working group and mostly worked on model signing and was a maintainer of Guac in the past. I can still contribute to that. And been working in ML and security for the past almost 10 years. So I'm here to talk to everyone here. Thank you.
Thank you, sir. Next up, we have Marcella. Could you introduce yourself, please?
Sure. So I'm Marcella Millara. I'm a research scientist at Intel. I'm also an OpenSSF TAC member. So at Intel, I've been leading sort of internal and academic and also open source projects that focus on software and AI supply chain security. So I'm a maintainer on a couple of OpenSSF projects and in Toto, if people have heard about that. And so, yeah, I'm very excited to be here to talk about some of the stuff that I've been doing.
Excellent. We have a lot of experience here. You're going to learn a lot of interesting things. We're going to kick it off with my friend Sarah, where she's going to do a deeper dive into our recent white paper. Sarah, please take it away.
Yes, so let's move to the next slide. All right, so earlier, about a couple months ago, back in, I think, August, we published a white paper. It's Visualizing Secure MLOps, or MLSecOps, and this is a practical guide for building robust AI/ML pipeline security. This paper is available. I've got the link in the slides, and then also maybe if someone from our colleagues and friends in operations might post the link in the chat, that would be very helpful. All right, so let's dive into what's in this white paper. Next slide. All right, so there's some additional information that's kind of been pre-wired and published. These are great resources to leverage after the Tech Talk. There's a statement about the white paper. There's a blog, but I wanted to take some time on the call to kind of dive into this. So we've been working with software and open source software, whether we've been building it or using it for decades. And if you're on this call, you're probably passionate or curious about how to secure these applications. And one of the things we saw, I don't think it's any surprise to anyone on this call, is that more and more of these applications that our software developers were building or open source projects that we started maintaining were leveraging artificial intelligence. And so what we learned was that software developers were increasingly being exposed to this new world of AI. And people who are creating AI, such as a data scientist or someone who works in machine learning engineering, they were being exposed to partnering in production-grade scalable applications. And so these two very different personas are converging on this idea that we need infrastructure and processes that allow us to do these AI applications in a way that's repeatable, observable. We can have good, long-standing operations and security governance. How do we do that? Do we need some brand new ideas that we've never looked at before? Or are there things that we can do, lessons that we've learned from software application that we can apply to this AI space? And what we realized is that this idea of DevOps becoming DevSecOps and that transition over time of how we develop and securely operate an application applied very well to AI applications with some caveats. And so while we want to build on a foundation of what we know, we also want to be able to articulate what's new and different. And so now that really comes to the operations of machine learning secure operations, or MLSecOps. What's inside this white paper is personas and different people who care about this, a reference architecture, an explanation of how DevOps transitioned to MLOps, and a layer-by-layer visual that kind of builds out tools and actual processes that you can follow as you're learning about securing machine learning operations. And we think this is really important to be able to train our software developers and people working with AI in our community in the security leadership that we have established in the OpenSSF space. So anyone who's creating AI apps, anyone who's consuming an AI application, this is a white paper that can provide some really good knowledge and foundational tools that you can use to upskill yourself, to have conversations with security practitioners around you, have conversations with your peer engineers, or people who are working in your OSPO, or maybe even new people that you're being exposed to through data science. All right, so let's kind of dive into two of these images. There's a lot more in the white paper, but I wanted to start out with this next image, which is our initial origin story for where the reference architecture came from. So this reference architecture generalizes it's a generalized MLOps reference architecture that was put together by a team of experts in Ericsson. And they published this reference architecture, and I loved it. And I wanted to help amplify it in partnership with them and others in the OpenSSF to say, well, what risks do you close with this reference architecture, both software risks and AI risks? What tools can you use to mitigate those risks? What kind of people work in different stages of this reference architecture? Layer by layer, as you go through the white paper, it builds to a visual that talks about risks, controls that you can use to mitigate those risks, and tools that you can use as examples of those controls. All right, so we're going to go to the next slide. It's the bit of, we've skipped the building it layer by layer, so just prepare yourselves. But this is kind of the final value that's in the white paper as you go through it. So next slide. Okay, this is the final layer. So you see we have a legend there that talks about where there are threats. We leveraged the great thought leadership of OWASP in coming up with the top 10 ML threats and security tools. We brought in from OWASP. We also brought in from OpenSSF. And I think now would be a really good time to transition to our next speaker, who is going to talk about some work that they did to evolve the tool from working in a developer perspective to be inclusive of machine learning operations. So I think if you progress this slide one more time, it's going to point out this idea of model signing and how we've extended a tool called SigStore with the idea that if you can sign code and validate that code has been signed, you should also be able to validate a model, cryptographically attest that a model has been signed. So at this point, we're going to move on from talking about the white paper. I'm going to hand it over to Mihai to really talk about the thought leadership that he has done in the space of model signing.
Thank you, Sarah. I'm going to talk about model signing and how we can establish trust in artifacts. We have all over the past 3 years, we have been building a lot of awesome and cool AI projects, but there is still one bit of problem, as exemplified by this XKCD problem, and we will see it on the next slide. That problem is, next slide, please, the AI supply chain security. Basically, if we move to the next slide, we see that in general, to get a model deployed into the ML application, there are 3 different stages. We have an initial training that is being done to build a foundational model. This is being done in general by big companies, by foundational labs, where ML developers are training big LLMs on the entirety of the internet, but to make the model perform well on NLP tasks. However, these models are not useful for specific tasks. So there is the next stage of fine-tuning where developers are taking a foundation model and fine-tuning the model to perform well on a specific task. And then after this, there is the team of software engineers that embed this model into the application itself. As you see, there are already 3 separate teams, and most likely these teams are in different companies. So the way the model moves from team to team is by putting the model into a model hub and then taking it from there. This also means that while the model is at rest on the model hub or while the model is fine-tuned, it can also be compromised. So next slide, please. We are looking at ways where the supply chain for models could be compromised. And we identified the entire diagram for how a model gets built from data sets where you can iterate on the data set, do data cleaning, data transformations, merge data sets together, training a model either directly or using a pre-trained model and fine-tuning it, or combining an ML source and ML framework. Once the model is trained, it gets put to a model hub to be used in further rounds of training or to be elevated to a production model. That's when it gets embedded into an application, and then the application gets used by users. And we have identified that there are supply chain compromises at every stage into this development, into this timeline. And we started looking at ways where we can secure this. So we started first with making sure that the model that gets trained by one entity cannot be tampered with by the time it reaches another entity. And this is model signing. We sign the model when the model gets trained, and then we verify it each time it gets used, either when the model gets deployed to the model hub, or when it gets elevated to a production model, or when it gets used in further rounds of training. Next slide, please. So a question that usually arises is, why did we need a different solution for model signing compared to traditional artifact signing? This mainly arises from the way ML is different. A model in ML is a collection of arbitrary files. And in general, when somebody trains a model, they are training the model for different formats. So for TensorFlow, for Hugging, for PyTorch, for GGUF formats, for safe tensors, and so on. However, the user doesn't need to use all of the files. A user that only uses PyTorch framework only cares about the weights in the PyTorch format. So we are into this state where the producer of the model needs to sign all of the files that they create for model, or all of the artifacts, but the user only cares about a specific subset. At the same time, training and inference for very large model is done in a distributed environment, and we don't want to stop the entire process while a single host is doing signing or verification. Furthermore, there are so many model formats, and it will be very hard to adapt adopt signatures into each model format. So instead, we looked at a way to do detached signatures. So rather than changing the model format, we just add a file into the model format or attach to it. And then we also wanted to be both future-proof and support all of the current pipelines. So we wanted to be PKI agnostic. So we support both signing with Sigstore, as Sarah hinted at, but we also support signing with signing keys, signing certificates, like in traditional PKI infrastructure. And we're currently working with integrating this into the model hub, such that when a trainer trains a model and publishes it to the hub, it immediately gets signed and verified by the hub. And then as the model user, you can either download the model from the hub, and the tool that you are using to download the model performs the verification. Or if you don't trust the hub and the tool, you can also check the signature by yourself. Next slide, please. So for the model signing with Sigstore, this is the framework that we are using. The model trainer will connect to the Sigstore certificate authority with the workload identity token and get back the short-lived certificate that Sigstore CA gives to you for signing. Then the model training pipeline would sign the model and would upload the signature and the certificate to the transparency log, getting back the log inclusion proof. And then the signed model, the certificate, the proof, and the model itself will be uploaded to the model hub, at which point the model hub can verify the signature and then display a verified badge on the model hub page. Users that trust the model hub can then just download the model and use it. Users that don't trust the model hub can download the signature and verify it locally by themselves. Next slide, please. So here I show you two screenshots from Kaggle, from the current integration with Kaggle. This is still work in progress, but when you upload the model to Kaggle, Kaggle can verify the signature. And once it is verified, it displays this Sigstore status signed and a link to an attestation on the model page. If you trust the Kaggle framework, if you trust the model hub, you can either just download the model and assume that it is verified, or you can click on the attestation link and you get a notebook that you can run to verify the signature by yourself at the time that you are running the notebook. If you don't trust Kaggle at all, you can actually download the signature itself. Inside the model files, there is a .kaggle directory that contains the signature. You can download everything and run the CLI tool that we are providing to actually verify the signature. Next slide, please. You can also verify the signature itself into the record transparency log that Sigstore has. In this case, I show a screenshot looking at one of the signatures that we generated for a model. We can see under the validity that the certificate is valid for like just 10 minutes. So only during those 10 minutes, the model could have been signed. And then looking at the subject, we see that the email that has been used to sign is associated with Kaggle, is basically the user ID at Kaggle. And the OIDC issuer is also Kaggle. So basically this says that Kaggle has been signing and verifying the model at upload time. And people can monitor the transparency log to find out what other models are assigned into their name and so on. Next slide, please. We also got an integration of model signing into the NVIDIA model hub. Right now, if you go to NVIDIA and look for different models, you'll see that they have the signed label displayed next to the version. Every model that gets published to the NVIDIA model hub since April is now signed. And I show here two examples, one from an NVIDIA model, and the other one is the Llama model uploaded to the NVIDIA model hub. And next slide, please. So in the future, we want to get into a state where every part of the ML supply chain is protected. This includes signing data sets, signing models, and verifying this wherever they are used, but also getting proofs about attestations about every step into the process. And with this, I can turn off to Marcela to discuss more opportunities into securing the supply chain.
Thanks so much, Mihai. So yeah, I want to start the conversation about opportunities and emerging efforts. Click, please. Thanks. With the question around what does it mean to trust a model? Because as we've been talking about, right, like this question actually has quite a bit of nuance. If we actually dig deeper, it's got a lot of underlying questions. And if you click again, please. Model signing really only very effectively covers sort of the first two questions. Where did this model originate? What components make up this model? But there's a slew of other questions that we don't have great tools to address effectively yet in a very verifiable, how should I say, like machine verifiable way. We may have some sort of human-centered mechanisms for answering questions about pipeline specifics, pipeline configurations, data sets, right? Even the ML frameworks like PyTorch, they may contain vulnerabilities. We've seen that in the past as well. So as Mihai was saying, if you can go to the next slide, please. There are some emerging efforts that a colleague and I out of Intel have been leading around machine learning model lifecycle provenance. I won't go into the sort of nitty-gritty details. Please watch our talk at Open Source Summit this past summer. But what we're trying to achieve here is essentially collect metadata about the machine learning artifacts and the pipelines as a model is created from this very beginning of data set preparation and data collection all the way to inference. This metadata then allows us to establish a cryptographically verifiable graph of model lineage, so we can actually begin to make claims, but also validate sort of the model lifecycle end to end. And in our project that I'm going to describe a little bit more in the next couple slides, also includes trusted execution hardware, because this can allow us to provide a sort of root of trust for the integrity and the provenance information that we're actually generating. So if we go to the next slide, I want to start with just, again, what a very sort of typical model lifecycle looks like from data processing all the way to inference. And so I won't go into the threats again that Mihai just covered, but what I want to show is how our project called Atlas essentially modifies the life cycle. So if you click again, please, there are several things that Atlas essentially adds to map a model's life cycle end to end. And so we start with this provenance module that we run alongside each pipeline at each stage of the life cycle. And this provenance module handles metadata collection. It monitors the inputs and the outputs of the pipeline. It monitors actual pipeline operations in some cases. And it can also then generate this authenticated metadata. So in our current implementation, we use the Coalition for Content Provenance and Authenticity. I got that right. C2PA format for the metadata. The reason for that being that this format was established as originally as a way to capture similar information about how media online is modified and sort of transferred between different parties. And so that working group has been very active in trying to adapt that format and that standard for machine learning. And so we wanted to start there. Anyway, so besides the provenance module, these sort of bolded boxes you see with the lock symbols around each pipeline signify running the pipeline or components thereof inside of a trusted execution environment and hardware to, again, provide that kind of trust foundation for the signatures and the metadata coming out of the pipeline. And so you can see that very much like in model signing, we sort of extend the same flow of signing artifacts, signing metadata, and storing that information into transparency logs. So by the time you reach the inferencing stage, we have collected essentially a whole signed provenance chain for the whole model across the life cycle. And that can be verified by the Atlas verifier. Any stakeholder, not just model users, can validate results if they're willing to trust the Atlas verifier or obtain this information themselves. So yeah, you can hopefully very quick, in my very quick summary, see how something like Atlas can sort of extend what model signing gives us. And so if you go on to the next slide, what something like the Atlas framework can begin to provide is, I guess, what we call this end-to-end integrity and provenance and transparency. And I always like to emphasize that we focus on integrity because in order to test these other properties that are extremely important, like privacy, confidentiality, safety, quality, there are many others, we care a lot about being able to attest and validate those properties in a model as well. But without integrity, the trustworthiness of that information is maybe more difficult to establish depending on your sort of security and trust requirements. And so I put up the QR code here for our current CLI tool that is out there in open source. We just merged support for model signing into our tool, and support for Salsa is actually coming up. We have an open PR for that. But in general, we think that this work would greatly benefit from sort of broader engagement with the OpenSSF community. So we're definitely working towards transferring this work into OpenSSF as well. Okay, so on the next slide, I also want to cover another emerging effort that our group has been leading around GPU-based integrity for LLMs. And so the goal here is to really take advantage of the performance improvements that we can get from offloading, hashing, and signing on a CPU to a GPU. We essentially get very efficient cryptographic hashing and signing of models. I think there's some work being done on data sets as well. And I should say there's parallel work coming out of Purdue University in this space as well. So the sort of, I should say, specific or unique aspect that our sort of branch of this work brings is that we combine new and existing trusted hardware features and standards. So we combine confidential virtual machines for CPU-based integrity and attestation. That's because that's sort of the entry point for a lot of these operations still. And then we use a standard called TDISP that essentially describes how to implement secure CPU to GPU communications. And so in our case, we're using the Intel Trust-Domain Extensions hardware that sort of offers both TDISP support and a confidential virtual machine environment to, again, on Intel GPUs, Intel Xe GPUs, to sort of provide this GPU-based integrity for LLMs. But we are developing a proof of concept at the moment, and because we are sort of also beginning to work together with the folks in Purdue, we're looking to establish a unified framework for different hardware architectures, since they have so far focused more on the NVIDIA GPU side of things, just because, again, there's a lot of benefit to being able to abstract away some of those details when you're actually doing model signing. And so we're, again, sort of working towards integration options with model signing, and hope that this will become another OpenSSF project in the near future. And so I want to wrap up with talking about the many opportunities that exist for securing the AI lifecycle. Of course, here in OpenSSF, we've been very focused on developing and adopting or encouraging adoption as well of supply chain security practices in AI and machine learning, right from the white paper that Sarah talked at the beginning, through model signing, through some of those emerging efforts. But we think that there are many more spaces. So there are sort of 4 that I want to highlight, starting with AI-assisted code generation and being able to capture provenance there, to model and training, privacy and quality and safety, and being able to capture sort of those properties, again, in a sort of machine-readable way through the supply chain. Of course, agentic AI is sort of the buzzword of the year, but there's a lot of work to be done there. I also want to highlight supply chain practices for algorithmic techniques like guardrails that could further bolster just the many benefits that they're already providing. And so I want to leave everyone with a call to action to get involved. Join the AI and Machine Learning Security Working Group. The next meeting is next Monday, September 29th at 10 a.m. Pacific time. And the working group is starting to see a lot of different special interest groups or SIGs pop up. And so the cyber reasoning systems is going to focus on scaling the AI XCC sort of competition candidates there and sort of make those more widely available in open source. And SafeMCP begins to look at how we can secure agentic systems. I also encourage folks here to not only look at OpenSSF, but there's a lot of really good and important work happening in other communities like COSI and LFAI and data. I know all of us on this panel today frequent these different groups. And so it's really important that we sort of keep the communication channels open. So we've got some meeting times up here as well. And in general, we've talked a lot about tools and specs and emerging sort of projects that are happening. So try them out, contribute, join the meetings, open issues, PRs, all of that is just really important in this like very rich and active space right now. So yeah, with that, I'll hand it back to Krob. Thanks so much.
Thank you, thank you, thank you. And I would encourage everyone on the bottom bar of your Zoom window, there is a Q&A feature. We have a couple questions queued up, but while we get more questions waiting, we have a very special guest star. Dr. Wheeler has an AI-related announcement. David, do you want to come off mute and kind of share your amazing news?
Yeah, sure. So hello, everybody. Thanks for letting me slip in here. We're obviously all sorts of AI is impacting lots and lots of different situations, communities, and so on. We in the OpenSSF have also developed a guide and a free course on using AI to develop software. The guide's already available. It's called Security Focused Guide for AI Code Assistant Instructions. Gives you, how do you provide instructions to these code assistants to generate more secure code? On October 16, we're going to be releasing a free course on how to use these AI code agents. It's called Secure AI ML Driven Software Development, LFEL 1012. It's going to explain how do you use them securely, how to develop and review software so it's more secure, and it builds on that guide that we've already released. If you're curious, if you're interested in that, sign up. We have a little sign up form where we'll email out to everybody who is interested, so you'll be notified when it's released. And just full credit, both of these are joint projects between the OpenSSF's AI/ML working group and the best practices working group working together. I'll post, let's see, do we have a chat or I've got some text we can post in. Why don't I just post it here on the everyone chat, and if that's the wrong place, then someone can recopy it to the right place.
Well, that'll be great, David. Thank you.
Thank you.
So I would invite our panelists to come back onto the screen. We have a couple questions queuing up. And again, if anyone has additional questions, please leverage that Q&A button. First question comes from Mark. And I'll let whoever would like to jump on this. Does C2PA incorporate a distributed ledger?
Yeah, I was actually already typing up an answer for that one since I mentioned it. But yeah, I can just speak to it. So it may, but it's not a requirement. C2PA, the C2PA specification focuses more on how the metadata is represented, what needs to be captured. And so the main verification requirements there is that the metadata be essentially each component of an artifact, or I think C2PA calls it assets, but same thing. So they need to be hashed with a cryptographic hashing algorithm, and they need to be digitally signed. Beyond that, I see no reason why anyone could use a distributed ledger on top of that to sort of provide a more global, auditable sort of, should I say, platform for that. But yeah, it's not a requirement of the specification.
Excellent. Thank you for that. Our next question was, can we use the OMS? Mihai, do you want to grab this one?
Yeah, definitely. So right now you can do pip install model signing, and this gives you both a CLI and a library that you can use. So you can use the CLI to sign and verify models directly from the command line. And the library, you can integrate it directly into your pipeline. The library is the one that we plan to integrate with the model hubs and the model frameworks. The OMS specification is extracted to a separate repository such that people that are writing their pipelines in Go, in C++, in other languages can also target the same specification.
Excellent. Thank you very much. So while the audience formulates some more questions, panel, we got a little insight into all the activities of the foundation, and we got a little taste of what's coming. So maybe I'll ask each one of you in order that you've spoken, kind of what's the next thing inside this AI security space that you are most excited to see? We'll start with Sarah.
Yeah, I think for me, I really liked this slide Marcella shared at the end, where we're really talking and leaning into the supply chain, but there's also these other areas of interest. And so with this, there's an opportunity for the OpenSSF to have a strategic program around AI ML security that would have a variety of different things on the roadmap. Personally, I would say the area that I'm most interested in and spending quite a bit of time exploring relate to that special interest group that Marcella mentioned on Safe MCP, and also supporting the adoption of the cyber reasoning systems.
Awesome. Mihai, what are you most excited about as I collect a couple more questions?
Yeah, so I'm really interested in getting model signing and dataset signing and provenance across the entire ML supply chain. My ideal goal is that maybe in a year or two, we can actually use Guac to understand the AI supply chain, to have a full telescope into that, and then react to compromises and so on immediately via tooling.
That would be awesome. And Marcella, forthcoming stuff, what are you most excited to see in this AI security space?
I mean, I think so. Beyond the work that I presented, I'm actually pretty excited about the Safe MCP work as well, the cyber reasoning systems, and sort of seeing how all of that can come together. I know I mentioned several other areas, and so I think just, yeah, in an ideal world, all of those. But yeah, I think the sort of very burning, I guess, questions and topics are definitely, I share the excitement.
Very fast-paced space. Blink and you'll miss 28 new technologies. Let's go back to our questions. We have one of our guests asked, how do AI ML bombs fit into this securing the AI lifecycle and to help instilling better trust into AI models? Anyone have a thought around AI ML bombs?
I can take that one. So we have been looking at the ways in which we do software bills of materials, and looking to understand, as you bring in data sets and as you bring in models, how might you want to communicate those in addition to the software for kind of an end-to-end view of the data and models, which make up those AI components in your application. So as an example, through the Linux Foundation, there's a specification called SPDX, and their 3.0 release of SPDX has a data and a model profile in it that you can use to complement what is in your software bill of materials already. I know the other format is CycloneDX, some great work happening over there in the OWASP team, and they've also had quite a bit of conversation and dialogue about how to take information, similar to how we took information from software. How do we take additional information about models and data? And they've been leveraging it in their format. So I think, to me, that where I see ML AI bombs kind of fitting into the securing AI lifecycle is in communicating dependencies and components used in a similar way in which we do that for software.
Very nice. Thank you. Marcella.
Yeah, I also wanted to add a point though about sort of using those AI bombs, right? Because there's even with S bombs, there's still a lot of sentiment in sort of in the industry around actually using that information to our benefit. So I hope that the people sort of developing these specifications can sort of start thinking about that aspect as well, because otherwise we'll just continue generating a lot of data and not putting it to good use.
And that's actually a topic we talk about as part of our SBOM Everywhere SIG, and then our new SBOM Coffee Talk that happens every Monday. So if you want to talk more and specifically about AI bombs, that would be a great place that you could engage our community and other SBOM luminaries across the ecosystem. And Mihai has a comment.
Yeah, something very short. So right now, to generate the SBOM for AI, in general, people are looking at spreadsheets. They're recording every step that they took during the development of the model or scanning the model at the end, but that is not giving too much details. So my goal with getting Guac to actually work for ML is to actually be able to ask Guac, generate an AI bomb for this model, given all of the information that you already have ingested into Guac.
Very nice. Our next question, it goes back to the model signing project. Are there any beginner guides to try it out? This person's new to SigStore. They saw some blogs, but we were curious, is there a more kind of beginner guide either existing or in the works?
Yeah, so we have on the model signing repository, we actually have a Jupyter notebook, a Colab notebook. I just shared it in chat that showcases how to use model signing both from the CLI and as a library, signing both with keys and with SigStore. And we can always extend the guide and write more. As part of the separation to MS, we actually want to provide more documentation and more golden files like this is the signature from this format. This is what we want to be able to always verify no matter how the project proceeds in the future.
Amazing. Thank you. A couple more questions. The next one is, how can companies looking to leverage and build AI ML infrastructure protect their PII and developer workstations from overeager data ingestion that these models seem to have? They want to try to not pollute the training data. And are there any sources or any recommendations you could have that somebody could think through about that?
I can start. So one of the things that I think is very interesting is a lot of people who are very eager to use AI and who are experimenting with AI are software developers. And I think this is a good opportunity in the industry to have partnerships with security practitioners as we're creating and developing these applications. And so I have some recommendations that I found very helpful for kind of activating the security instincts of software practitioners as they're engaging with the kind of the new use cases that software engineers are talking about related to AI. And I think it's because the attack surface is infinite. If you start to look and bring the scope down by looking at the use case that the specific business or outcome is trying to deploy, and then the method in which it's being deployed, now you really kind of reduce that attack surface down to be able to understand the risks. And then you can begin to say, all right, well, which tools do we think we need in place in order to reduce those risks? And there's some great documentation being put out by the MIT kind of AI risk repository. The Cloud Security Alliance is doing some really great work related to kind of understanding and securing against AI risks, as is OWASP. So those would be kind of three areas that I would start with on some of their technical documentation. But in order to best apply it to how maybe PII or developers are using AI, I'd start with the use case. I'd think about the deployment and kind of dial in the conversation, and that will really help you activate conversations with your security teams.
Marcella.
Yeah, I just really want to sort of second Sarah's point about like threat modeling also and all of that. I know we've seen a lot of more privacy-oriented, confidentiality-oriented approaches coming out of sort of the big cloud providers around AI inferencing. So I know that that's, I guess what I want to highlight there is that things like confidential computing solutions are a great start, but not quite enough, right? Because as the question like points to, right, there's a lot of data coming in from different places going out. There's so many different actors. And so I don't know if we're quite in a place yet where we can say just like this is the solution for confidentiality and privacy. Yeah, it comes back to the threat model and those kinds of things. But I think we have seen a lot of really good sort of different ways of doing this and sort of common patterns. And I expect we'll sort of see more of these sort of common patterns emerge, and maybe eventually we'll get to a point where we have that.
David, you have something to add?
Yeah, just real quick about the whole, hey, I'm worried about, some of this data being used as training and so on. A number of these, AI related AI companies are already aware of this. They have various mechanisms. This is not an endorsement, but just as an example, if you use Cursor, they have something called privacy mode, where that expressly disables any training on it. Another possibility is you can do things like use local models. I think in many cases, though, the use of local models isn't necessary. The first issue, yes, we're in a new world in some ways, but a whole lot of this stuff is old stuff, old school. What is the threat? Figure out what the threat is. How do we address the threat? For example, if you're worried about training, first of all, maybe some of that data shouldn't be there. Okay. If it is okay to be there, a lot of these organizations will be delighted to sign a contract that says we're not going to use it this way, we will use it that way. There's many ways to deal with it, but you have to identify the threats first, then look at your alternatives. And for some of these things, I think there are fairly obvious trade-offs, but solutions.
Well, before my friend Angela gives me the hook, I would like to again thank our panelists and our special guest star for sharing their wisdom and expertise in this space. This is a constantly evolving set of technologies, lots of acronyms. We'll try to address any questions we haven't done here offline, but I will now turn it over to my friend Angela to bring us home.
Thank you, Crow. Hi, everyone. Just a quick CTA on what we discussed today. So please check out our working group and some of the resources that the speakers have mentioned, including the white paper and some model signing tools. And also wanted to mention that these are a couple events that we're participating or hosting this year, including the European Open Source Security Forum in October and the Europe Roadshow, actually a day before the Security Forum. And we're also hosting Community Day in Korea and our colo with the CNCF KubeCon called Open Source Security Con November in Atlanta. So the schedules are live and registrations are live. So if you haven't registered yet, please check it out and register. And I'll hand it over back to Crow.
Great. There are a multitude of ways that you can get involved. First off, please consider attending a working group or project meeting. All of our meetings are free and open to the public. You don't have to be a member to participate and collaborate with these experts like we have on the panel here. We have all of our meetings are listed in our public calendar. So anything around the open source security space, whether it's application security, AI security, repository security, we've got a special interest group or a working group that's probably working on that you may be interested to take a look at. Every single one of our groups has at least one Slack channel, if not more, depending on how they're structured. And everything is stored within GitHub. So those are all public repositories. and most of them have mailing lists. And as always, if you're interested in actually becoming a formal member, we have a pathway to that as well. And our next slide. Great. We are on all the socials. So keep an eye on typically hashtag OpenSSF or at OpenSSF, depending on what the platform is. You can learn all about the amazing things our community and these experts like these are working on every day. Next slide. There's a quick button to sign up for our mailing list, openssf.org/sign up. Next slide. If your organization would like to join, openssf.org/join. Next slide. And again, I want to appreciate Sarah and Mihai, Marsala, and David for sharing their time and expertise. Reach out to them in our Slack channels, and thank you, everybody. Happy open sourcing, and I hope you got a little bit of wisdom today from these amazing folks. Enjoy the rest of your day.